Now onto our second environment, Google Container Engine. Google Container Engine is a hybrid service product designed to run containerized applications, and we'll start this section by introducing Docker containers and the Kubernetes container orchestration system. A concise definition of a container is that it provides lightweight application virtualization. We're familiar with virtual machines, which virtualizes a computer at the operating system level, providing CPU, memory, disk, and networking resources to the operating system. OS-level virtualization is resource-intensive. It would be common to allocate multiple cores, gigabytes of RAM, and disk space to run a single virtual machine. If we installed every part of our application onto a single virtual machine, we potentially run into the problem called works on my machine, where each part's dependencies are uncontrolled. Containers are a response to the desire in modern application development to keep each component part of an application in a controlled and isolated environment. With containers, each piece of software is packaged up into a standalone image, but it's not a full operating system. Only the libraries and settings needed to ensure that the application can run are included. So it's easy to ensure lightweight, self-contained, and reproducible deployment of your application. The most popular software for containerization is Docker, although it's not the only format. With containers, it's easy to package software for deployment. We also need to deploy and run our containerized applications. Kubernetes is an open-source container orchestration system created by Google that enables you to manage containerized applications. An in-depth discussion of Kubernetes is outside of the scope of this class. Just be aware that you'll be able to exploit the same types of features that we've seen for creating resilient workloads on Google Cloud Platform. For example, Kubernetes supports auto-scaling and load balancing using a declarative format. Google Cloud Platform includes several resources to support containerized software. Firstly, Google Container Engine enables you to create a cluster to run your Kubernetes applications. Secondly, Google Container Registry gives you a secure location to store your Docker images that will be deployed to the Container Engine cluster. So what does this mean for ASP.NET Core applications? Well, first, we need to publish our application, and we do this with the .NET command line tool's publish command. This builds an output DLL file that's used as the entry point of our application. Next, we can turn our attention to packaging up our application as a Docker image. We do this by writing a Docker file, which is the specification that enables Docker to build the image. This slide shows the entire contents of the Docker file. Microsoft maintain an image for .NET Core, which we use as the starting point for our ASP.NET Core web application. Recall that we said, in a containerized environment, the image contains only the libraries and configuration needed to run the application. So starting with the Microsoft.NET base image, we copy over the files from the publishing step into our new application image. The next statements configure the network environment. Recall that by default, ASP.NET Core applications run on port 5000. We could configure Container Engine to map this port to make it available, but later on, we'll be using this Docker image with Google App Engine. And App Engine requires that our web application should listen for requests on port 8080. So we expose port 8080 from the container and then set the environment variable that ASP.NET Core uses to configure its protocol, IP address, and port. The final statement is the command to run when the container starts. Notice how we're running the .NET command and providing the DLL generated from the publish step as the argument to the command. This will start the web server. Now we have our Docker file. We use it to build our Docker image. Remember that the Docker image is a complete isolated application that can be executed on a container runtime, such as Docker's own runtime or Container Engine. This slide contains the complete set of commands to run on the command line to create our Docker image, store it in the Google Container Registry, then run the application on Container Engine. The first statement builds the Docker image using the Docker command line utility. The -t switch provides a tag for the image, and the format must follow the specification on the slide, with gcr.io / the project ID / then your choice of application name. The command on the slide contains a placeholder for your project ID, so you'll need to replace it. Also, it's really easy to miss off the final period, which means the current folder. This command is running in the folder that contains the Docker file we wrote previously. Next, we use the gcloud docker command to push the image up to the registry. Again, you must use the same format string used with the docker build command. Finally, we use the kubectl command line utility to deploy our application. There are lots of ways of doing this, and we've picked a simple one, as we only have one container to deploy to our cluster. Using kubectl run, we specify our choice of application name, the image to use, making use of the format string for the image in the registry, and the port number where the application is listening for requests. Our containerized application is deployed, running, and listening for requests. However, we need to expose the deployment to allow clients to connect to it. We do this with a final kubectl command. You can see that with kubectl expose deployment, we can easily set up a load balancer and tell it that requests from clients on port 80 should be routed through to the containerized application on port 8080. Now it's time for a demo where I'll create a cluster on Google Container Engine. Then I'll take the ASP.NET Core application, publish it, write a Docker file, and finally deploy the application to Google Container Engine. This demo is part 2 of a 3-part series focused on running ASP.NET Core applications on Google Cloud Platform. In the first part, we showed how straightforward it was to create an ASP.NET Core web application that ran on a Google Compute Engine Linux instance. In this demo, we're looking at another product in the GCP Compute family, Container Engine. Container Engine enables you to deploy and manage containerized applications. It's a production-grade service based on Kubernetes. Kubernetes is an open-source container orchestration framework. So in this demo, first we'll create an ASP.NET Core application using Visual Studio 2017, then publish it to Container Engine using the Google Cloud Tools for Visual Studio. So let's get started. You can see that in this demo, we've already created the backend data store for our application, which is Microsoft SQL Server running on Compute Engine. You can also see that we have 3 machines which begin with the letters GKE. This stands for Google Container Engine. If we browse to the Products and Services Container Engine item, then you'll see that we've already got a Container Engine cluster. We'll be able to publish to this directly from Visual Studio. So let's go over to Visual Studio now. Okay, so here we are on Visual Studio. Let's create a new project. In the New Project dialog, we can select the ASP.NET Core Web Application item. We need to give it a good name. I'm going to call this Where to Eat Core. Click on OK, and the project will be created. As we've seen before, we're going to select a web application template. This will give us an MVC application. Okay, I'm going to add some code to this. I'll pause the video while I do it, and then we'll come back. Okay, we're back. I've added a model class called restaurant, and that has properties ID. This is going to map to our record in our SQL Server database, and then string properties for the restaurant name, city, cuisine, and price range. I've also added in another class called feedMeContext. This has a collection of restaurant model objects in a property called restaurants. When we run our application, then you can see we get a home page that's displayed. And then if we add restaurants onto the end of that, then there's our content, just like before. So that's really good. All we need to do now is to publish it into Google Container Engine. So to publish our application, I'm going to right-click onto the project and select Publish to Google Cloud. I'm going to choose Container Engine, and from there I have a cluster, the cluster that I already set up. I've chosen a deployment name, and finally I want to expose a service and make it public and open the site after publishing. By doing this, we'll get a public IP address for our application running on the cluster. Click on Publish, and the tools will go and do their work. And in a few seconds, we'll have our application up and ready running on Google Container Engine. I'll pause the video while that happens. Okay, we're back. So what I want you to notice up here is that we have an IP address. This is a public IP address for a load balancer on Google Cloud Platform. Our application is deployed to Google Cloud Platform with ASP.NET Core. If we add restaurants onto the end of the URL, then just as we've seen previously, we've got our application. So that's pretty good. That completes part 2 of the demo, where we've shown how we can take an ASP.NET Core application and deploy it to Google Container Engine.